Welcome to Build or Buy It. I'm Mike and this is episode 2 of the from scratch built 20-ton hydraulic press. In the first episode, if you didn't see that, you can go back a few. It was basically just going over the design parameters and a little bit of the CAD drawing and discussion about what the press is going to look like and the function. So I did get the steel in the shop. You can see here in the background, I brought it in on that work trailer that I used for building the tandem axle equipment trailer, and it makes a good platform to hold things up off the ground, and it's almost the same height as my saw, so I'm able to just slip the material up in the saw. So the first step on this is, of course, to get that 20-foot stick of channel, 6-inch channel, cut down into a manageable length. So I'll cut both of the longitudinal uprights, the 2 table cross members, and then the 2 upper cross members that hold the ram itself. So without further ado, we'll get going on that, and then I'll talk a little bit about how I'm going to bore the quite a few different holes that hold the table. One side note before I do get going on that is, in the last episode, that little side episode I had on the Makina planer joiner, I realized it didn't really do a recap on the build it or buy it portion of it. So really the only costs I had was that urethane that I used and the quick release, and that was right at about $60 for the material. The freight was a killer. It was $38 to get it shipped. I could have saved some money on the freight because that product is sold on Amazon, but that particular model, that 770 series that I needed, they didn't sell that on Amazon, so otherwise I could have saved that shipping. So at any rate, I was into it with tax right like $101 and some change. And as I mentioned, depending on where you buy the rollers, they were anywhere from, $500 for both rollers, $500, $600. So I saved somewhere in the neighborhood of $400 to $500 on resurfacing those rollers here in the shop. So anyway, that's a recap on that. Let's get going on cutting this steel. Couple things you may have noticed. You probably noticed, I'd start and stop some or feed some, and the reason being, when you're the cold saw is meant to do just that, not generate a lot of heat. And this is pretty thick channel, and so when I'm coming down through this top plane, as you can imagine, you're engaging a lot of the teeth. Versus when you're cutting through here, you might only be getting 1 or 2 teeth at a time. Here you're engaging lots of teeth, so it's you're going to build considerably more heat when you're plunge cutting down through a broad piece of metal. So 2 things can happen if you don't give it a little bit of a break to cool off. One, the blade starts to get warm enough it'll actually warp a little bit and then starts dragging in the kerf groove. The second is you can actually get this warm enough to start work hardening it, and then you'll notice it doesn't want to cut as well, and then if you don't bear down and get through that harder layer, you can get yourself in trouble. So anyway, that's why I kind of pause. And then once I'm through that first layer and get into these legs, then it just cuts right through those like butter. Just to give you a feel for kind of the precision and the repeatability on that saw, because I used a trailer spindle and 2 tapered roller bearings for the table. That 20-foot piece is kind of gangly to try to cut the precision lengths out of that 20-footer. So I basically measured out the 3 pieces that I needed that would get me near half. Added about 3/4 of an inch to allow for the saw kerf, and cut it off there, and then cut the pieces to exact length. So that very last piece, I had to shave off that tiny last little bit. And so this is that piece that I shaved off. You can see it's very uniform, so that says that the repeatability as far as clamping in the vise from cut to cut is very good. So not losing my mind. As you probably saw me flip it end for end there, and you're probably thinking, well, it's exactly the same from end to end. The reason why I flipped, I'm not losing my mind. The unlike pretty common for channel or 20-foot pieces to get banged up on the end from being moved around in the yard. So this end nearest the camera, that's the issue with it. The flanges are bent in a little bit, and so as is normal, it was about 2 feet longer, or 2 inches longer than 20 feet, so that's ended up being a drop. So because the far end is the fresh cut end, I'm measuring back from that end, so that's why I had to flip it end for end. Okay, so those are cut to length on the table pieces. If you remember from the CAD drawing, those have a little bit of a green thread right. It's going to make me draw left-handed. So those have, instead of being square cut, if this is the long length of the channel, they have a little bit of a shape like this, if you recall. And then there'll be a pin out here, and that retains, and the 2 pins here, that lets the vertical channels fit through here. So I've got to cut that, cut those tapers. I'll probably do that probably with a torch. So I got that to do next. Or I got that to do at some point. That won't necessarily be next. The only really kind of tricky part of this, or part that's, I guess, a little more critical, is the holes. I'll use the Harbor Freight here one as an example. So are the tip you down a little bit more, are these holes here that the pins fit in that hold the table. Since there's obviously holes in both flanges of the legs on both sides, you want, when you're pressing things, you want that table to come down and sit flat against the pins. You don't want that table racked at all. I mean, it would in essence flex enough to straighten itself out, but you want those holes as nicely spaced evenly and uniformly as you can. Side to side, from the left side of the upright to the right side, that wouldn't be the end of the world if they were a little bit higher or lower. That just means the table would tilt a little bit, but still, if you're trying to push something nice and square, you still want that as close as you can. So to accomplish that, drilling holes in steel, especially with larger drill bits, that's why I kind of like the unibits for that purpose, is that the unibits make a nice round, or a rounder hole. They're still not perfectly round by any means, unless you're going to put something in a milling machine and using bore and bar or a reamer to get it round. So using, those are a 7/8 inch pin that I'm going to use. So to try and cut those holes with a 7/8 inch drill bit, even if it was a unibit, they won't be very round, and additionally, they'll be, if the drill bit is perfect, that'll be the exact nominal size of the pin, which is 7/8. So 7/8 pin doesn't fit in a 7/8 hole. You need some clearance. And if I was doing those on a milling machine where it could be guaranteed everything was as close as possible, you could get by with very, very little clearance. But because I'm going to do it on the drill press, I need a little bit more clearance. And so what I ordered was, I'm going to do these with these holes with an annular cutter. Let me grab those here so you can see what they look like. Okay, so I had to do a quick little bit of math to explain what I'm going to do here. So the first thing to go over is I'll show you an annular cutter if you haven't ever seen one. They do a really nice job of making a nice round hole, as well as it being on size. So they look like this, and they make them in all different sizes. This pin in the middle, it floats, so you can use that as it's kind of going to help you align it. It's not tight enough. Once you start cutting, it doesn't do much. It's mostly just to help you locate over a center punch hole. Typically they're used in a mag drill, and which is very rigid, or in a milling machine, which is also rigid. So we'll see how this goes on my drill press. Because they all use this type of a shank. I think it's 7/8 if I remember. No, it's not. I think it's 3/4 with 2 flats on it, because as you can imagine, there's a lot of torque required, and it wouldn't hold in a regular drill chuck. But they do make these adapters that go into a standard Morse taper drill press, and then they convert over to this shank. So you can run them in a drill press. There's a little bit of flex there. So anyway, that's the method that I'm going to use to drill the holes. And as far as the clearance goes, you can get them in some oversizes, but it varies. Sometimes you can get it in a few thousandths. So the closest I could come was a 23 millimeter annular cutter, has a outside diameter of 905 thousandths, and the pin I'm going to use is a 7/8, which is 875 thousandths. So that'll give me some clearance. So if there is any slight misalignment in the holes, the pin will still go. When you look at the Harbor Freight, they're like probably, I'll bet you there's close to a 1/16 of an inch, maybe even more. So it's going to be very similar, maybe a little bit tighter tolerance than the Harbor Freight. So that should work out okay. So I'm probably going to do that next, work on, because I want to kind of get that done, make sure that's going to work out okay. So I got a little bit of setup work to do on the drill press. I'm going to clamp a fence on the drill press table. That'll locate the holes in one axis, and then I'm going to use an indexing pin. You'll see, I'll show you how that works out. An indexing pin when I switch from hole to hole, to that way the uniformity, the distance between the two holes is very consistent. So so come on back if it should be in this episode, but if not, come on back on the next episode and you'll see how I'm going to get these holes made. There is one thing I wanted to show you. As you guys know, I don't have a milling machine. Most people don't, but that doesn't mean you can't try to at least maximize the precision of what tools you do have. So given these holes need to be fairly accurate, anytime you can make sure the table on your drill press is as square or perpendicular to the spindle as you can, it just gains in accuracy. Granted, there's wobble in the quill itself, but you can still get the table as flat as you can. So I just got an old beater dial indicator that I use for stuff like this, that I just put in a put on a shaft, and then that goes in the chuck, so then I can sweep or tram the table in. So there's not, on a drill press typically there's nothing you could do front to back. That should be pretty accurate from the factory. You potentially could shim this one swivel joint underneath, but that's kind of going to extreme. This one happens to be nice and perpendicular front to back, so I was just checking the left to right. So I've got a dial indicator here, and it'll be hard to kind of see. I'll switch to the other side. All right, so we were 0 right there, and as we swing it around, we're gaining to where we're off by, I can't read the camera backwards, but in essence we want to split that distance half. Come back around to this side. We're at 15. We're about 7 there. Drop my hammer. So we're going to go back to about 10 is kind of what we're shooting for, and then I'll zero it. So we'll come back here. I'll zero it again. So there we got 0. And we got about 2. So at any rate, again, it's a drill press, so thousandths are kind of irrelevant for all intents and purposes, but it certainly doesn't hurt to try to take advantage and whatever tooling you do have to make it as accurate as you can. Okay, so we're just about ready to get busy drilling the holes in the uprights. I touched on the annular cutters a minute ago, so I'm going to show you how that's going to play out and kind of what my setup is here on the drill press. So as I mentioned, I need to try to do those as accurately as possible and as repetitive as possible. So switch over here a little, better angle. So I've got a fence out of a piece of scrap 6-inch channel clamped down really tight to the drill press table. I squared it to the table. It's this angle between this flange and the face is always fairly close to square, but it's not perfect. So I had to shim it a little bit on the back side and checked it with a precision square. Not the most critical thing in there. If I was boring both flanges at the same time, if I had enough depth of travel and if the holder was smaller than the annular cutter where I could go all the way through both sides, then this angle pitching this way would be very critical, because if it wasn't straight, one hole would be in a different place. But since I'm only going through the thickness of each flange, that angle is not super critical, but at any rate, so it's not like I needed to sweep with a dial indicator, but I did check with a precision square. So I'll clamp my piece of angle up here. Let me grab, here's this piece of scrap. So I'll just set it up there so you can kind of see. So that will get clamped up here. The offset amount, you could probably see there. Let me run the cutter down so that you can see. Let's see about how much. You can probably see there how much it'll clear the inside of the channel by 1/4 inch or so. That'll keep the pin pretty close to this surface here, add a little bit more strength. So that's the setup for the fence. And then also for the repeatability, what I talked about was using a pin type setup. So once I drill the first hole, I've got to check the prints that, if I remember right, the hole to hole, center to center was 6 inches. So once I drill the first hole, I will move it ahead that exact amount, whatever that is, if it's 6 inches. And then I've got this little ear here, right here, that's got a hole in it. That same 23mm hole. And then I put this in the lathe and bored that to just a really snug fit in that hole. So once I drill the first hole, I'll slide the piece ahead, whatever that distance is, 6 inches. Then I can use this pin through this ear that's clamped. I'll probably actually tack weld it so there's no chance of it moving. I'll drop that pin through into that first hole. That locates that hole exactly, and then it's a rinse and repeat. I'll drill the next hole, slide the channel ahead, drop the pin in. That verifies that that hole will remain, that spacing between the holes will remain consistent. I could lay it all out, center punch each of them, but that does leave room for a cumulative error. So this way, it's a much more accurate way of keeping the hole spacing even. Then I'll flip the channel end for end and side for side. I will have to transfer the one hole. I'll use, again, the precision square and go around the other side and probably the optical center punch, so I can get that first opposing hole lined up as close as possible, and then I'll just repeat that process on the second flange and do that times 2 on both legs, and hopefully all the holes would be done where they belong. So I'm going to get the first piece clamped up there. I'm going to set up a couple roller stands to support it as an in-feed and an out-feed, and I'll bring you right back. Okay, so I've got my setup finished. One other thing that I didn't mention a second ago, and you maybe saw in the intro clip, kind of the tongue-in-cheek intro clip of the drill press being on an IV drip. That was obviously tongue-in-cheek, but it's somewhat exactly a rough representation of what I'm actually doing. So I'll pan you down here. I'm using there's some trade brands out there, and there's some off-brand stuff, but basically you can see here on the side of the drill press, the small nozzle, and then this what looks like an IV tube going down to, oh, you can't see it there, it's behind the piece angle, but right down here, there's just a 2-liter bottle that has a water-soluble lubricant in it, and that little device on the side of the drill press, it's just got a mag base on it, and it has 2 little regulating knobs. Bring it back over here again. It's got 2 little regulating knobs right here and right here. One of them is for the airflow, and the other is how much of the coolant lubricant it draws out of that jug. So, and its purpose is, instead of using a cutting oil, which you could use, but cutting oils are, they don't offer a lot of cooling characteristics. They do offer good lubrication. So the advantage of this setup is you get the air blowing on it, so it helps keep chips clean. You have the water-based coolant and lubricant that cools the cut as well as lubricates it. Doesn't make too much of a mess, a little bit, but compared to, let's say, flood cooling on a milling machine, it's considerably less messy than that. So I'm going to go ahead and get started on this first hole. My memory was correct. I checked the drawing, and it was a 6-inch spacing in between holes. So after I drill the first hole, I'll shift ahead exactly 6 inches, and then that'll let me clamp down the piece that holds the alignment pin for the next one. So the fence is clamped down tight. I've got the first upright clamped into position for the first hole. I've got my roller stands there and here set up to help support the weight. Not that it's a big piece. So I've got the drill press turned down on a slower speed. So I'll get the flow going. The flow might make enough high-pitched or high-frequency noise. I don't know what the volume will be like. I'll adjust that when I edit the video, but hopefully it's not too obnoxious. Okay, that's the first hole there. And as you can see, that centering pin that I talked about for being helpful for alignment, once the cutter starts, it's self-centered, but because that's spring-loaded, it ejects the little plug out of the bottom of the cutter, so you can move right on to the next hole. So I'll shift it down here, be 6 inches, and get the guide plate. This guide plate here, it's just sitting there clamped roughly in position. Now I'll get it more accurately positioned. The way I know it'll be 6 inches is when I scribed this hole, I came down exactly 6 inches and scribed the next hole. So now I'll put the annular cutter center point on that mark. That will move this hole 6 inches. And then I'll just put the pin through both this bracket and the hole I just drilled. That puts the bracket in the correct position, and I'll clamp it in place. So I'll get that done and bring you back. Clamp that. It probably wouldn't move any with just the clamp, because it's not like there's any load on that, but the last thing want to happen is this to slowly drift, because then that would start making all of the holes be incorrect. So I'll show you. So I think I will bring the welder over here and just tack this in place. I'll give you a quick look here of top down on that hole. So you can see that lines that hole up nicely. That plug drops in, that locates it in the correct spot. So I'm going to tack weld this in place and bring it right back. Okay, so I got that tack welded. That also let me take the vice grips off permanently, so they're not in the way now of the handle. So now all I got to do is just insert the pin each time. So we'll get going on the rest of these holes. One other area where the annular cutters really shine is, and I've used them at work before, is if you have a hole that's worn from, doesn't matter whether it's a pin or what it is, and that hole is egg shaped. If you try to drill that hole, and let's say you just want to upgrade to the next size or pin, bolt, bushing, whatever it may be, and if you try to run in the next size drill bit through that, the odds are that egg shape is no longer on the true center line axis, and that drill will automatically find kind of a center based on that egg shape. And so your new hole may not be in the proper location in an annular cutter because it's not even cutting in that section. It does a really good job of, you just set up over where the hole needs to be, and it doesn't bother it to cut heavier on one side than the other. So it does a really good job of putting a hole back where it belongs. So I've got one hole left, so that, and because it's channel, if it was tubing, I could flip it side for side, or if these holes were centered, I could flip it side for side. And so I would reference off of this flanged edge, but it's not. The holes aren't centered, they're closer to the, so when I flip it over, I also have to flip it end for end, and I'll be starting down here on this last hole. So before I actually finish the last hole, I'm going to bring it down. I'll put some mark out layout down here. I'm hoping that the center plunger will put just a little bit of a mark on there, and then I can use that with the precision square to transfer that hole over, that location over to this bottom flange down here. I'll just transfer it around the backside, and then so when I flip it end for end and flip it over, that will give me a new starting point. So I'll get that laid out and bring it back. Okay, so I've got some layout marker on there. That plunger is not actually keyed into there, so it's not like a drill bit that'd be forced to spin, but it's going to turn just based on friction. So again, I'm hoping that it'll leave just enough of a mark. And I can see there that it did. I'll beam in here really close. That's just one shiny spot. I'll flip it yeah, that gives you good, that little shiny spot is where it's going to touch. So that'll give me a good reference mark to transfer the other side before I drill the hole. Thought I'd show you another, I guess it kind of falls into a tool category out there that I used to have super good eyesight, and as I get older, not so much. So I find myself a lot of times grabbing a flashlight or a headlamp, and I don't like the big bulky headlamps. So there's these have been out for a while, but I thought I'd show it because they have a couple nice features. So it's a headlamp that's just the LED, that's the yellow stuff. It's just on a rubber band. So super light, fits over your head. There is in the battery packs a little bit bigger on the side, and it's got a spot beam. So I'll turn it on here. Hopefully it doesn't make the... So it's quite bright, has 3 different levels, and then the spotlight. The one feature that's kind of nice, especially if you're, say, a mechanic, and like I've done, and you've got grease on your hands and you don't want to reach up and turn it on and off, you can turn on, there's a button for a sensor, you turn that on, and then when you just wave your hand in front of it, it turns off. So you can have it on the side of your head. Instead of having to touch the switch or your greasy fingers, you just wave your hands at the side of it, and that turns it on. So anyway, they're like $20 on Amazon, so they're kind of a cool headlamp. Okay, that gets that scribed line on there. So now I can go back, drill that last hole, or bore that last hole, and then when I flip it over, I'll have a good starting point. Okay, so there's the last hole. Realistically, I probably wouldn't have had to do that many holes, but it's not that often that you really have something that tall that you have to put in a press. But since I was here, might as well do the holes, and that way the table will go almost all the way to the floor. So that's the reason why I did. So that gives me, what, 6, 7 holes. So that'll be 28 holes total that I have to do, 25% the way done. So I'll get it flipped around here and bring you back. Okay, so I've got it flipped around here. As you can see, the holes are now on the bottom flange. So I flipped it around end for end and top to bottom. So I now have, I'll do the same exact process but going the other direction. I'll probably just do 1 hole here, just so you can see that last hole, and then since it's basically rinse and repeat for another 20 or so holes, I'll just bring you back when I've got all done. So I think I'm really close to about a half an hour on this video, so I'll probably wrap it up after this hole, and then see you back at the next episode where I'll start doing some of the assembly. All right, so we'll see you on the next episode. Thanks for watching. Like, subscribe, and ring the bell.